Hello, TransMath class. We're going to take a look at lesson 13, and in this lesson we're going to just compare some of the rules for multiplying and dividing fractions, and also there is an activity where we explore the angles in different polygons, mostly in a square and in a triangle. When we change one of the angles, how does that affect the rest of the polygon? Okay, so in example 1, we are going to either multiply or divide. And it looks like for part A they're asking us to multiply. So remember, before we do any multiplying, we want to look to see if we can cancel any of the same numbers that are in the numerator of one and the denominator of the other fraction. And we have 3's in common, so I'm going to cross those out and make them 1's. And then we're going to multiply straight across. 1 times 2 is 2, and 4 times 1 is 4. Now examining this answer, 2 and 4, hopefully you notice that we can divide both of those numbers by 2. So we're going to do that. And we're going to simplify our answer. 2 divided by 2 is 1, and 4 divided by 2 is 2. So 1/2 is the simplified answer. Okay. And then in a comparison to dividing fractions, so when we multiply, we do some canceling if we can, but then we just multiply straight across and try to simplify our answer. But before you do anything with division, you need to rewrite your problem as a multiplication problem. So we are going to rewrite this one as 3/4. Instead of divided by 5/6, it's going to be times 6/5. Okay, so that's our first step, is to rewrite the problem, set it up as a multiplication. Now I'm going to look, do I have anything to cancel? Doesn't look like it. So if that's the case, we just multiply across. 3 times 6, which is 18, and 4 times 5, which is 20. Now when I look at 18 and 20 and I'm looking for any common factors, the first thing you notice is that they're even numbers. And so if you do notice that, 2 will always be a common factor. And let's go with that, because I can't think of anything else that goes into both 18 and 20. So if we divide by 2, and remember, if there was something else, we can always reduce it further in another step, so that's okay. 18 divided by 2, 9, and 20 divided by 2 is 10, and that is a simplified fraction, 9/10. There's no common factors there. Okay, example 2, similar. We're just going to compare multiplying and dividing, and this one 3/5 times 3/6, no common numerator denominator to cancel, so let's just multiply across. 3 times 3 is 9, and 5 times 6 is 30. All right, so now we want to see what can we divide both the 9 and the 30 by. What would be a common factor? And 30 doesn't divide by 9, so we can't go with that, but the other factors of 9 are 3 and 3. So 3 does go into 30, so let's use that. We're going to divide by 3. 9 divided by 3 is 3, and 30 divided by 3 is 10. So 3/10 is our simplified answer there. Okay, next one, 4/5 divided by 1/5. So again, divide. We have to rewrite the problem as multiplication. So 4/5 times 5/1. And now we're looking for any common numbers in the numerator denominator. So we have this 5 that we can cancel. Cross that out, make it a 1. And so now I've got 4 times 1 is 4, and 1 times 1 is 1, and 4/1 is just equal to 4. All right, in the applied skills portion of the notes here, it says in activity 1, in each problem there is an error. Find and describe the error. Explain how you know the solution is wrong, then fix the error and solve the problem correctly. Okay, so they're telling us in this problem it's incorrect to write 3/5 times 1/3 as 3/5 times 3/1. And then they just went through the process and multiplied it and got 9/5. Well, multiplying, 3 times 3 is 9, 5 times 1 is 5, that's all right, but their mistake was this was not a division problem, so they should not have flipped the 1/3 over. They should have just multiplied as it was, okay, or did some simplifying first. Okay, so the error is they flipped the fraction on a multiplication multiplication problem. And that's not what we do. We only flip the second fraction on a division problem. So how do you know the solution is wrong? I think this statement pretty much says it, because that's an error. You don't do that, right? So let's fix it. So the original problem was 3/5 times 1/3. And so let's do this correctly. We can cancel the 3's, and then we can just multiply across. 1 times 1 is 1, and 5 times 1 is 5. 1/5 should be the answer, not 9/5. It should be 1/5. Okay, and this one, okay, so we have 3/4 divided by 1/2, and you can see they mixed up multiplication and division, because in this one they did not flip it, and it's a division problem, so the 1/2 should have flipped over to 2/1, right? So the error was they did not flip the fraction. How do you know it's wrong? Same reason. They didn't flip the fraction and they have to. So let's do this correctly. So 3/4, when it says 3/4 divided by 1/2, that means that we have to take 3/4 times 2/1. So 3 times 2 is 6, 4 times 1 is 4. And we're looking to simplify this, 6 and 4. Both even numbers, let's divide by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So 3/2 would be the correct answer, not 3/8 like what they said. Okay, the last part of this is going to be just exploring what happens when you change a given angle in a polygon. So the polygon just means it's a shape. It's like a square or a triangle, or maybe it's a trapezoid or a parallelogram. So it just means that it's an enclosed figure, okay? Something where we can measure the angles and the sides. Okay, so the directions do ask us to use a protractor and a ruler. Because we're not handing those things out, I'm just going to have you just draw this the best you can without a protractor and a ruler, and we're just going to talk about whether the angles are obtuse, acute, or right when we're done. Okay, so that says, then draw the new polygon with the measure of the one interior angle changed as indicated, and then describe the polygon. Okay, so it says, in the new polygon, change the indicated angle to an acute angle. They mean the angle that they're pointing the arrow to, so this corner, the bottom right corner of the square, we're supposed to change that to an acute angle. It says the lengths of sides A and B in the new polygon should have the same lengths, so those shouldn't change. So this side on the bottom and then this side on the left side, those need to stay the same length. Okay. Now, probably to keep this a little simpler, just because we don't have a ruler and a protractor, what I would do is I'm just going to redraw the figure right on top of the current one that we have, and that way we can use the same length for A and B, since we're supposed to leave those the same. But I'm going to change this right angle into an acute angle. Okay, so when I do that, I'm just going to go from this corner and I'm going to say, okay, well, I'm going to make this angle right here acute. So now instead of 90 degrees, it's something smaller than 90. So then what I'm going to say is I'm just going to scribble up, pretend like these sides aren't there anymore. Okay, so my new polygon is what I'm outlining in red. Okay, so B and A are the same length, right? But now this angle, I'm making it an acute angle by kind of cutting diagonally through that angle and making it smaller than 90. Okay, so now it's less than 90, right? Okay, so now what we're supposed to do, it says in the new polygon, change the indicated, so we did that, and we left sides A and B the same length. But I think what they want us to do is just kind of talk about how the rest of the polygon changed. It says then measure and record the lengths of the sides and measure the interior angles of the new polygon. So let's just talk about when we changed this angle, what else changed? Well, A and B did not change. We left those the same. This 90-degree angle stayed 90. This one didn't change. But side C became shorter, right? We can see that because I kind of closed up this angle, and it connected here now. So now I've got more of it would be a trapezoid technically, but side C now is only is only this long, right? It's only from there to there. So side C is shorter by changing that angle. And I think the other thing that would have happened is the top right angle right here became an obtuse angle, right? So when we made this angle acute down here, it caused this angle to become obtuse, okay? And I think we talked before that if you add all the angles in any quadrilateral, they add up to 360. So if you make one of them smaller, that means another one has to get bigger because they still have to have a sum of 360. Okay, so side C is shorter, and the angle, which isn't labeled, but I'll just say the top right angle is now obtuse, which means it got bigger because it was a right angle before. Okay, so those are the changes that we saw there. Okay, and in the last one, it says, in the new polygon, change the indicated angle to have an obtuse angle. The length of side A in the new polygon should have the same length as side A in the given ones. Okay, so we don't want to change the length of this bottom side. That should stay the same. Okay, but the other things can change, and we have to change this angle here, this 90-degree angle, to an obtuse angle. So we want to make that bigger than 90. So in the same way, I'm just going to go from this corner right here. I'm going to go from this corner, and I'm going to open this angle up so that it's bigger than 90. Okay, so if I go kind of like that, now I'm going to have an angle that's larger than 90. So that's an obtuse angle now. And then I'm going to have to connect from this corner here to wherever I end this one. Right, so if I kind of connect that like that, and then I'm just going to kind of see, I'm going to scribble this out to me, show like when we redo this, these sides are gone then. Okay, so our new polygon is what I've done here in red. Okay, this new triangle is going to be this right here. Okay, so we changed the angle that they pointed to. We left side A the same length. That's still the same. Okay, so then what happened? And when we did that, it meant that well, this angle down here in the bottom right corner got smaller, right? Because the 90-degree angle had to get bigger. And again, since the angles in a triangle have to add up to 180, if you make one of them bigger, then something else has to get smaller because the total has to equal 180. Okay? All right, I think that's pretty good. I know there's a question where you have to draw something like this on the test, so I want to show you how that looks. We'll review it again before we would take the test as well. Okay,